Hello everyone. Today I will be talking about basic graphs in RStudio, and we are basically working on our Markdown. So our objective is to familiarize ourselves to create some scatter plot. We will start with scatter plot. That means we will show some relationship between two variables and then familiar with handling parameters. So you worked on Excel to create some graphs, also pivot chart, but then again we don't have access to all parameters. That's why we are working on R programming so that we can control all possible parameters in our graphs. And then you will see that we will be creating some high quality graphs so that you can actually use it in your documentation in other courses. Also for publication you can also use these graphs, and you will also be learning how you can set some margins in graphs. Sometimes we don't need that much space in one area, maybe we need more space in the title or maybe at the bottom. So then we will be deciding on where to leave how much space. Here is the basic graphics lecture slide. So you will see that we started with producing the graph. So you can see in this graph I have shown height and age relationship in two data sets. So based on the color we added, we mentioned that what are they. So we are saying that we have the crown class and two kinds of species. So you can see we have species 3 and species 5. So that means we have two species. We would like to see where the height, you can see the height trend in those two kinds of species, where we can see the higher height trend, where we can see the lower height trends, and the minimum maximum height. So you can see in this graph. So in R, while we are creating graphs, we use plots and we use some commands. Within the plot function we can add many parameters. Also we will be using histogram, and we will be creating some histogram using hist function, and the bar plot using bar plot function, and then we will also be adding points or lines. Let's say in here you can see we are using points, but later on you will see that if we want to show some growth of trees, we will be joining those points. So that means we need to create some line graphs as well. So what will go in x-axis, what will go in y-axis from our dataset, we have to mention that just like we did in Excel. Okay, so now we need to download this file, this RMD file, and after we run this RMD file, I got this Word file. So this is the output file, and you can also create the output file for yourself. So we will be using VRI data, but I gave you two formats. So you can see I gave you VRI data in CSV format. I also gave you VRI data in R data format. This is a kind of data that R actually can read. We don't need to write any code for that. So you can download these, and at first we will try to use this R data. Okay. To use this R data, what we need to do is that let's open this R Markdown file in RStudio, in R Markdown. So all we need to do is to go to our folder, and on our folder you can see we have this R data, VRI data. So right click the data and say open with RStudio. So you will see that it asks me whether I want to add it into the environment. That means in here, if I say yes, it directly adds the data file in here. Same thing for RStudio Cloud. So I brought this R Markdown file, I open this R Markdown file, and then I need to upload that R data, the VRI data. So I just say that open the VRI data, So it opened the data, but there is one more step we have to follow. So we need to bring it in here. So you can see we have the VRI data in our data form. Then we need to bring in using this load workspace option. So let's select that, and let's say I would like to bring this R data into the environment. That means I can directly use that. If you have any trouble using this R data, then you can use the CSV file that I gave you. And if you are not sure what to do, you can go back to the previous lecture. You can see how we can bring in the CSV file. If you already have this R data, then you can add it as a comment, because we already have the VRI data. Same thing for our RStudio on the desktop. So we already brought in the data, then we don't need to use this code because we already have the R data file. And then at first we need to attach the VRI data so that we don't need to add the $sign. Let's attach the R data. Okay, so we attach all the variables, and then I say that I would like to create a scatter plot, age versus height. So I just name the variables, then I say that create the plot. Then you will see that it creates a plot. But you can see in here some values are after the limit, after 500. That means we need to increase the limit. Also over here you can see some of them are touching the border. We want to keep everything inside the border. Another item is that projected age 1, it just takes the name from the variable, but we need to add here a meaningful name, projected age 1, projected height 1, or sometimes we would like to add a title in here. So we need to do a lot of work to make it look nice and publication quality, to make it publication quality. To do that, all I did is that at first, to show you how each parameter works, so I added some more parameters in here. So you can see at first I did not add anything. I just added the mandatory items, x-axis and y-axis data. After that I added more. So you can see over here I added x lab. So what is x lab, what is y lab? So let's show you what I meant in there. So if I add question mark and if I say plot, so what we have in plot, so it will give you description of them. So that means you can see I added x lab, I added y lab. So over here it says that x lab is the title for the x-axis, y lab is the title for y-axis. That means I added what will go on the x-axis. So you can see x-axis I wrote it differently. So I said that in the VRI data use the third column. That means age is on the third column. On the y-axis height is on the fourth column. That means I'm using all the rows and I'm using only just one column, the height column. Then I say that add comma whenever we have new parameter, and I added x lab. That means in the x-axis I want to add this level as a title of my x-axis. As a title of my y-axis I would like to add that. So you have to separate all of them by comma. Also you can say I added unit. That means age is in years, not in month, not in days. Height is in meter. You can write meter or you can write m. The type, you can see over here, type is telling me what kind of plot you want to do. Is it a point, or is it a line, or is it both, point and line both? So I say that I would like to create a point graph. That means the values will be shown in the graph as a point. And then PCH is the what kind of symbol you want to add. I will talk about it from the slide. So on the slide, you will see that PCH, that means what kind of symbol you want to add. If you add 0, it will give you this symbol. If you add hashtag, it will give you this symbol. If you add 23, it will give you this symbol, and 9, this symbol. So I added one symbol. And for color, you can use any color you want from here. So that's what I shown in the PCH 16. That means I use the symbol 16, and then color, COL equal black, so I use just the black color. I will show you how you can change it to other colors. Then what's the limit? So previously you saw that it was up to 500 and it was not covering all the points, so I increased the X limit. Same thing, I increased the Y limit so that all the points are inside the graph area. And CEX is that expansion of your points, how big you want your points in your graph. And then in the lab, what's the size of those? So I will show you how, if I change them, how it's going to change in your graph. And then for the title, I would like to add this as my title. And then what's the size of the title? So you can see whenever we are talking about size of anything, then it's actually start with CEX, and after the CEX it says that what's the size we are talking about. If we are talking about the title, then we have to say CEX.main equals what's the font size. So let's actually create the graph, then it will make more sense. So I created the graph. So you can see I added the projected age, projected height, and then I also added a title in here. All my points are in black color. So if you want, you can make them green. So you can see I made it green and then change to green. And if I want to change it to another symbol, so let's say the symbol is 7 or 8. So 8 means this symbol. So let's say 8 equals 8. So you can see now it's changed to this symbol. If I want to reduce the symbol, the size of them, then you can see the size of those symbol is reduced. And then if I want to change the labels, that means the size of those labels to, let's say 3 is too big, I know. And then you can see it's too big, the x-axis and y-axis symbols. That means these titles of x-axis and y-axis is way too big. So let's make it 1.5. So let's run it again. Okay, now it's back to its original form. And then how about these numbers? So you can see it's not showing all the numbers because it cannot adjust the numbers. So all you need to do, we need to reduce it. Let's say make it 1. If we make it 1, then you can see we can add all these numbers in these ticks. And then we have up to 600, up to 70. That means all the points are inside and we can see all the ticks. So you have to make some adjustment whenever you are creating a graph. Same thing you can do in online. So you can just run this program and we have our data already, and you can see we added the graph, the color, and then symbol, everything we added. Okay, So you need to make some adjustment because you cannot see those two numbers. That means we need to make it a little bit smaller. Maybe let's say 1. Then symbols are too big. Maybe say 1.5. Then run the program. That means we adjusted and we created our graph. Now we are doing the same thing on the next chunk. So what we said is that we are defining the parameters at first, then we are calling inside the graph. So that means on the y-axis level, x-axis level, what we are going to add, we are giving them a name. That means defining them. So you can see, instead of writing xlab equals projected height or ylab equals projected height, instead of those, we are using these names. So that means we are defining them at first. All the values, you can see previously what went inside, we took out all of them and give them a name. So that means x-axis limit, y-axis limit, we gave it a name. And then what's the name we have for y-axis limit? So you can see ylm is the y-axis limit. That means we defined before inside our plot function, we just call them inside. The reason we are doing is that, let's say we are creating 100 graphs, then every time we have to name them, and then if we need to change anything, we have to go to those 100 graphs and then change them. Instead of doing that, what we can do, we can just add the parameter values before and then just change it here. Then we don't need to go inside those plot function. So let's see if I run them together. So you can see I'm getting the graph, but then you can see again it's not showing the values. Then you have to change it to, let's say, axis font size, let's say 1, and then it will change. Okay, if you find that the color is not right, then you can change the color. You can also give it a color, give it a name of the black color, and then add it after here after defining them. So in this chunk, you can see I plotted the graph, but then again I made the graph and then change many parameters so that I can show it to you. So let's say at first, again, we are creating a graph without defining. So you can see we created the graph, but we didn't define much. Now we defined, so we say that projected age, we gave it a name of the variable. This is age, and height is projected height 1, so we gave it a name. And then we gave names to all the parameters. And then I said that I would like to plot them, just a simple plot. You can see we added the graph, but then again I would like to change it to axis font size to 1, and then I have to run it again. Okay, yeah, okay, now it's adjusted within our graph area. Okay, now what I would like to do is to change the symbol on the previous graph. That means what we have previously on the first graph, we'll keep everything, only we are going to change the symbol. So previously it was 16, now I'm going to use 10. So let's see. Now you can see, change the symbol. Everything same. Now we are going to add a different color. So you can see color 84. So that means on the chart you will see that we can name the color, or we can add the number of the color. So there are many ways you can add the color in your graph. So let's say we made it blue, so color 84 is blue, and then we added different color. So let's say this one, really light color, and you can see I added this number. So if you go there, you will see that these are the numbers we can add. Okay. Now I added another color, another, you can see 68, everything same, only change it. So you can see similar color we have in 84 and 68. Okay, so after doing that, my interest is to add more graphs. So now you can see I gave you in a slide, I said, okay, so if you want to add a thicker line, then you have to use LWD function. Type is the point and the line graph, both are 0. You can use the line type. So you will see later we will be creating some line graph, then we have to use this type of line. 1 2 3 4 5 6, these are the line types. And then CEX is the size of your points. And then color, you can add different color name or color number, and then different point size, point symbol. Okay, so we would like to create more graphs. So let's go back to our graph where we have our RMD file. Then in here I say that I would like to plot two datasets on the same graph. So that means within the same area I would like to plot two graphs. Many different ways we can do that. So at first what I did is that I plotted, but then again I created the dataset first. So you can see within the plot I said that I would like to plot in the x-axis only for one species. So that means projected age 1, but then again it's only for one type of species. Same thing on the y-axis, I mentioned that only for one type of species I would like to add. So I showed you before how we can add this equal sign. Go back to the previous lecture if you're not sure how we are adding this double equal, so that we can actually add create another data set. So that means we are reducing our data, only creating graphs for one type of species. So you can see we have this graph, but then again we need to add the parameters. So the another way we can do it is the we can plot, but then again we add many parameters. So you can see I plotted one type of species first, and then I said that on the same graph I would like to add another species. So that means I created the data of another species and then I plotted them together. At first you have to start with plot and then add the data, add all the parameters. If you want to add it and then add another data set on the same graph for the point type, you have to start with points. If you start with plot, it will create a new graph, but we want to add everything in one graph. So you can see we added the first species CW, and then we added the PLC in the second. So that means first one is in one type of color, the color was black, another was the second type of species is in green. So that means this is the first species, the CW species, and this is the green is for the another type of species. But more easier way rather than this complicated way is that we can separate the data first. So let's say we are using this subset function that I showed you before. So using this subset function from the VRI data, we can create a data set only for CW species. And another data set is D2, where we added another type of species. So that means we are creating a data file in here. So let's show you. Over here right now we have only VRI data and nothing else. So in here, if I create D1 and D2, so you can see in D1 we have only one kind of species, and then D2 we have only PLC. So that means we created subsets of BRI data, and then we defined our parameters. That means we want to create age versus height, so we call them. At first I plotted the CW data, so you can see I use the D1 dataset. From the D1 dataset I use the third column, age, and then height is the fourth column I used, and then point graph, and I added all the parameters. Within the same graph I would like to add the second species, so I started with points. Okay, so let's plot them together. We have plotted them together within the same graph. We plotted both data sets. Okay. Let's see up to this point whether we can do the same. So on our cloud, let's create those graphs. Let's create these different types of graphs. So what you actually ran, you will see that all of them are showing separately. And then plot two datasets on the same graph. So that means two datasets, I plotted them together within the same graph. So I added this R chunk again, so that you can actually take them and then change them. Try to change the values and try to change these parameters and see what happens. So you can work on this part on your own. After working on plotting them together, two datasets together, so we would like to set the margin. So you can see in this graph we have less space on the left side, but we need to add more space on the left side, because you can see it's actually touching the border. We cannot see it entirely. Also on the right side, maybe we don't need much space because we're not adding anything in here. And then on the bottom, maybe we need more space. That means you can access the margin on your graph, and then you can see how much space you want in which area. To do that, you can see we changed the margin from the previous graph, and then we added margins, added more margins on the left side, and then more on the bottom. That means it looks way nicer than before. To do that, before we create the graph, before we plot, use the plot function, then we have to use this par function. In the par function, we have to say how many graphs we want. So let's say it's only one graph. We need to say one row, one column. So in MF row, what it says is that how many graphs we want. So let's say in a Word file, let's go in there. So let's show you in this Paint. So let's say I have to use the par function. So in the par function, we say that we have to add MF row equals C of 1 1, C of 1 1. Okay, so that means we are saying that we are going to use this. So that means MF row C11, this is telling me that in my x-axis, So in my x-axis and in my y-axis, that means how many rows, how many column I can have. If it says 1 1, then I can have, let's draw you in here. So let's say I have said 1 1. That means in the graph area I can add one graph only. So that means this is the x-axis and this is the y-axis. So if I say no, I would like to add mf row equals c 2, 1. So that means I would like to add 2 rows, 1 column. So that means on my previous graph, when we added that, we will be adding 2 graphs. So that means 2 rows and 1 column. So you can see we have 2 rows. So this is the first row and this is the second row, and this is column. That means we have 1 column, 2 rows. If I say no, I would like to add 2 rows, 2 columns equals c. We have to say 2, 2. So that means we would like to add more. So that means we need to add 1 more graph in here. That means we have another graph in here, and then here, and then here. So this is the first row, second row, first column, second column. So that means we created 2 rows, 2 columns. So that's how mf row works. So in after mf row, you can see mai. What that mai means is that how much space you want at the bottom. So let's say I added 0.9, so that much space I want at the bottom. And the second value is saying that much space I want on the left side, and then top, and then right. So that means bottom, left, top, right. So that's how it works. And what would be the expansion? You can use that. Expansion will be 1. Otherwise you will see that if you use 2, it will be way too big, the graph. Okay, so let's see in the RMD file where I gave you the code, how it works. Controlling margins. So in this controlling margins, we say that we would like to define the parameters first, run them, and then we can see one more item I added in here is that I would also like to show the maximum, at the maximum age, what would be the height value. I would also like to show that in my graph. To do that, I said in my D2 dataset that I created before for one type of species, so what is the maximum value of age? So you can see maximum value of age. I found the value, so you can run that, and then if you want to know what is the maximum value of age for that species, so you can see 177. Then I said after finding the age for 177 age, what would be the height value? So that means I am going to create a subset and then only going to add that maximum value. That means I'm only creating a data set for the maximum value. So you can see maximum value of the age 177. I only kept one variable information, one observation in here. So that means the projected height for the maximum value is 3. I would also like to add that in my graph. Okay, so after that, before we add the plot function, we have to define the margin. So you can see I added the MF row is 1 that means I'm only going to create one graph, and then MAI is the spaces we defined, how much space, and then how much, what would be the expansion. And after doing that, I added the plot function. Also I added the two dataset, first dataset, second dataset, and I also added the maximum for the maximum age, what would be the height. So all of them I added together. So you can see this is the 477 age, that's the height value in the second data set. I plotted two data set and I added the spaces. So if I change them, so let's say the maximum value I added should be in green color. I changed the color so that I can show you. So you can see now it's changed to green color. And then I say that margin, so let's say I add more margin on the left side. So for the left side, you can see the second value is the left side, first value is the bottom side. So for this is the bottom side, that means at the bottom, and then left is 1.1. let's say I added way less space, 0.5 on the left side. So if I run that, you will see that we cannot see the x-axis values, and then x-axis the name what we added in the x-axis. So we need to go back to the 1.1, otherwise way too small. 1.1. Same thing for bottom. If you add less space, then you will see that you cannot see see it entirely. So that means this is how this margin works. So let's run them. Okay, so if I change it to 5, the expansion is way too big, and then let's see, now you can see everything is expanded, and then we don't see anything in there. So that means when we were adding 1, it was way better. Then you have to play with these values, what we can see them. Okay, so that's the one. And then I gave you an exercise. So for, let's say, mean value of one of the data set, and then show the mean value in a graph. So that means I showed the maximum value. All I need is that instead of maximum, you need to find the mean of the value, and then I would like you to show that. Or you can add the minimum value or other values if you want. Okay, so that's it for now. I hope you enjoyed. Try to practice them, and then after you run any program, then save them and say need to Word. Same thing for cloud-based. You can run the program and run all chunks, and then save them and need to Word. Okay, that's it. I gave you the slide, and I gave you I will add this video in here, and then you can use the CSV file or R file. Thank you.